Now let's look at an example where we combine the general power rule with some other rules. Here we have f of x equals x squared times 3x plus 1 to the fourth power. We're supposed to differentiate, but also find all the x values where f has a horizontal tangent line. Well, we've got a product. We've got x squared times the fourth power of 3x plus 1. So I'm going to call x squared a, and I'm going to call the fourth power of the quantity 3x plus 1 b. Alright, so f prime of x would be a b prime plus b a prime. So a b prime would be x squared times the fourth power, or times 4 times 3x plus 1 raised to the third power. We need to multiply by the derivative of the inside function. That would be 3. Then we need b times a prime. So that's going to be 3x plus 1 to the fourth power times a prime, which is 2x. Alright, so I'm going to clean this up a little bit. This is 12x squared times 3x plus 1 cubed plus 2x times 3x plus 1 to the fourth power. Now, we want to find where the original function f of x has a horizontal tangent line. Well, remember, that's where the derivative is equal to 0. So let's set this function equal to 0 and solve for x. Okay? So 12x squared times 3x plus 1 cubed plus 2x times 3x plus 1 to the fourth power equals 0. Now I would try solving this by factoring. You've got two terms. You've got this term and this term. Terms are separated by pluses and minuses. So I would look for common factors, factors that are in common to those two terms. Well, we've got a factor of 2, we've got a factor of x, and we have 3 powers of 3x plus 1. Now let's decide what's going to be left once we take out that common factor. From the first term, we're going to have 6 and x, and, well, we took out all the powers of 3x plus 1, so that's done. And then for the second part, we took out the 2x, we took out 3 of the powers of 3x plus 1 to the fourth, so that's going to leave 1 power behind. And I'm just going to write that like that. Now we need to clean up that last factor. I believe that's going to be 9x plus 1. And now we set each factor equal to 0. So when we set 2x equal to 0, well, that's going to give us 0. And we actually have three factors of 3x plus 1, but each of those factors is going to give us the same result. So let's just do that once. If you subtract 1 and then divide by 3, I think you're going to get x equals negative 1/3. And then the 9x plus 1 equals 0 is going to give us x equals negative 1 divided by 9. So there are 3 values of x where the function has a horizontal tangent line. Here's our next example. We are supposed to differentiate this. Now you've got 3x minus 5 divided by sine squared x we've got a quotient rule, but we've also got this sine squared x. We've already differentiated sine squared x, if you remember. So I am going to rewrite this as 3x minus 5 over sine of x squared. Alright, so f prime is going to be the denominator, sine of x squared, times the derivative of the numerator, that's 3, minus the numerator, times the derivative of the denominator. And I'm going to use the work that we've already done. If I remember correctly, the derivative of the square of sine x was 2 sine x cosine x. And that's going to be all over sine of x squared, so that's going to be sine of x to the fourth. Now, I see a common factor of sine x in all the different parts. So let's take out a common factor of sine of x. And then here, that'll leave a sine of x times 3. Let's just call that 3 sine of x. And then we're going to have, let's see, we're going to take out a sine of x. That'll leave us with the minus 2 times 3x minus 5 times cosine x. Minus 2 times 3x minus 5 times the cosine of x. All over, well, we've got 4 powers of sine x. I'm going to break off one of them like that, and then get rid of those, and I think that's good enough. We'll just leave it like that.